Mole concept. Mole concept is the term or the idea that we use to estimate the amount of the substance in any chemical reactions. So what exactly is mole, or like what is mole concept? So let's talk more about it. A mole, or simply let's say a 1 mole. What does 1 mole means? 1 mole is basically a collection of Avogadro's number of molecules or atoms or anything. So just like we have 1 dozen. 1 dozen is a collection of any 12 items. Exactly like that, 1 mole is the collections of 6.02 into 10 to the power of 23. So now if you look at these numbers, we call this number as Avogadro's number. Avogadro's number, now represented by Na. So what we have is, let's say we have 6.02 into 10 to the power of 23. This number, how big is this number? Let's try to analyze this. So if you expand 10 to the power of 23, so that would look something like this: 10 to the power of 7, 10 to the power of 7, 10 to the power of 7, and this is 10 to the power of 2. So together, if we combine 7 plus 7 plus 7 plus 2 is 23. So 10 to the power of 7 is 1 crore. Okay. So how big is this number? This number, it is 6.02 crore times multiplied by another crore times multiplied by another crore times, and you multiply that by 100. That's how big is Avogadro's number. Now, why do we use Avogadro's number? Okay, why do we use Avogadro's number, or simply say, why do we use mole? Okay, so the mole, other way around, if we ask the question like this, why do we use 1 dozen? If we ask the question instead like this, have you ever wondered why do we use 1 dozen? Now, when we use the word dozen, dozen is a collection of 12 items. So instead of using a big number like 12, if we simply use 1, it makes our calculation easy. If we have to multiply 1 with 5, so we simply know that it is 5. But if we have to multiply 12 with 5, it will possibly take some time, and this is not a smart way of doing the calculations. 12 into 5 is 60, but instead of doing it like this, 1 into 5 is 5. So instead of saying it as 60 items, if we simply say it is 5 dozen, this is smarter. So for our easy calculations, we have introduced the words like dozen. Exactly for the same reason, if we have crores and crores of particles, and if we have to multiply that number, let's say we have to multiply, let's say we have to multiply 6.02 into 10 to the power 23 with 7. Okay, so it will be 42.14 into 10 to the power of 23. It is relatively a larger number and it will take a bit of time. But instead of saying it like this, if we simply say 1 mole and we multiply that by 7, so this is 7 mole. So this is easy. Okay, this is easy. So what we have done is, by introducing a word like mole, we are trying to produce the easy way of doing the calculations for some large numbers like 6.02 into 10 to the power 23 items. Okay, so why such large numbers? Okay, why such large numbers? Because in our day-to-day life you have to use a pen, pencil, or a chocolate or a biscuit. We hardly take, like, one biscuit, two biscuit, one pen, two pen, 100 rupees, 200 rupees. But we don't use crores and crores. Like 6.02 into 10 to the power of 23 means, like, one crore multiplied by another crore multiplied by another crore. We don't use such big a number in our normal day-to-day life. So that's the reason why we have not come across with 1 mole as of yet. But since in chemistry we are going to deal with the atoms or the elements which are very, very small, extremely small. These are the atoms which makes up any kind of substance that we see in our surrounding, or even ourselves. We are made up of atoms. These individual atoms, they are extremely, extremely small. So because of their small size, what happens is, if we take any small mass, if we, let's say, for example, let's take one simple biscuit or a chocolate. If we have a chocolate, let's say a small chocolate, have you ever wondered what is the number of possible atoms that could be there in the chocolate? So for these reasons, we understand that since the atoms are infinitely small, so there will be possibly a millions and millions and millions of atoms which would be there in a small piece of chocolate. Now imagine our normal average body weight is around 50 to 60 kg. So could you imagine what is the number of the atoms that we could possibly have in our body? Just a small piece of chocolate can have infinite number of atoms. In a large body like ours, we would have possibly much higher number of atoms. So in those scenarios, multiplying or doing the calculations with such kind of big numbers is not a smart way of doing the things. So instead of handling or using this such kind of big numbers, if we simply use 1 mole, 2 mole, 3 mole, 10 mole, like that, that is much smarter way of doing the calculations. So why are we using 1 mole for such higher numbers? Because we are going to deal with the atoms which are infinitely small. So because of their extremely small size, they would, or in any kind of object, their numbers would be extremely high, in crores and crores. So since we are trying to deal with those kind of elements, those kind of particles in large numbers, so it's advisable that we use the word mole instead of using such big numbers. Okay, so now let's talk about your more about the relationship of 1 mole with the other terminologies that can be associated with it. So 1 mole of a substance, this substance, it can be anything. It can be pen, pencil, rubber, chocolates, biscuits. It could be sodium, it could be carbon dioxide, it could be water, glucose, anything. So any kind of 1 mole of a substance, we should know that it contains 1 mole is nothing. It's just a count of a number. So that number happens to be the Avogadro's number, that is 6.02 into 10 to the power of 23. So since we are dealing with chemistry, so we better use the terms of chemistry. So 6.02 into 10 to the power 23 is 1 mole of a substance is 6.02 into 10 to the power 23 atoms or molecules of the substance. Now this atoms, okay, if we take the sodium atoms, okay, if we take 1 mole of the sodium atom, that is 6.02 into 10 to the power of 23 atoms of sodium. Their mass, if we measure their mass, if we take their weight in a balance, then we would get its mass as 23 gram. Okay, Now if we similarly take the mass of 6.02 into 10 to the power of 23 atoms of aluminium, its mass will come out to be 27. Okay, now exactly like that, if we take the mass of 6.02 into 10 to the power of 23 molecules of water, its mass will be 18 gram. Okay, so that means the 6.02 into 10 to the power of 23 atoms or molecules of substance would be equal to its molecular mass. The weight that we are getting is considered as the molecular mass represented by m. So m gram of the substance, molecular mass of the substance. Depending on the substance that you are taking, accordingly we will get the value of m. So here, let's say in the sodium, the value of m is 23. In the case of the aluminium, the value of m is 27. And in the case of the water, the value of m is 18. So depending on the molecular mass that you take for the substance, accordingly we will get the value of the molecular mass. Now, so what we know is 1 mole of a substance equals to 6.02 into 10 to the power of 23 atoms or molecules of a substance, and that equals to the molecular mass of a substance, and most importantly what we should understand is this many number of atoms. Okay, this many number of atoms or molecules or any substance, it has been found that their volume is the same. Their volume value happens to be 22.4 liter or decimeter cube of volume. Okay, this represents the volume. So this volume has been found to be constant for 1 mole of an atoms or molecules, and that value is 22.4. This is a fixed value and it won't change for 1 mole of a substance. So now what will possibly happen is we would get some questions related with, let's say if we have 3 mole of sodium, then what is the mass of that sodium, what is the volume that would be occupied by it, what is the number of atoms that is there in 3 mole of sodium. Instead of 3 moles of sodium, we may possibly again have 10 mole of aluminium. It could be anything. So to understand the mole concept further, let's talk about some more questions which will help us to understand better. Before we move into the questions, let me first give you some logic about the calculations. So let's say, for example, I'll just put a simple question like this. If 3 biscuits or chocolate cost you 2 rupees, then what should be the possible price of 5 chocolates? How do we do with this calculation? What we're going to do is you divide by 3 on both the sides. When you divide by 3 on both the sides, what we get is we get the price for 1 chocolate. 1 chocolate costs us rupees 2 by 3. Now we want it for 5. We want a price for 5 chocolate. So what we're going to do, we are going to multiply by 5 on both the sides. So the moment we multiply by 5 on both the sides, what we got is we got the price for 5 chocolates. 5 ones are 5. 5 chocolates will cost us 2 into 5 by 3, that is 10 by 3. So which is rupees 3.3. Okay, so this is not the important part. The important part is this. Okay, the important part is this, or like how did we get this particular step. Okay, it can be considered as very important. So this is the same logic that we would use to do our calculations related with the mole concept as well. So what we have is, we have got, let's say, a question like this: what is the number of moles present in 46 gram of sodium? Okay, we have a question like this: what is the number of moles that is present in 46 gram of sodium? So what we understand is, we have 1 mole of sodium. The first thing that you should always consider is the one that you know from the mole concept. So what we have is, we have 1 mole of sodium that equals to, since they are asking us to relate the mole with the mass, okay, we're going to use that. Let's say 1 mole. When we use 1 mole, we can have 6.02 into 10 to the power of 23 atoms of sodium. We will have 22.4 liter volume of sodium, and we will have 23 gram of sodium, which is the mass of sodium. Now since they are trying to relate, in this particular question they are trying to relate the mole with the mass, so what we're going to do, we are going to only keep the mole and the mass. We are not going to use the other two relationships. Okay, I hope it's clear with you all. So next, what we're going to do, since we are not going to use them, so let's remove it. This is what we have. Now the other point that we are going to consider is, as per the question, the value that is being provided to us is for the mass. This is given 46 gram of sodium, the mass is provided. So that means, what is the thing that we are supposed to find? We are supposed to find the number of moles. We are going to find the number of moles. So this is the one that we have to find. Always understand that the one that you have to find, you always try to put that on the right side of the equation. So since we are going to find the mole, so we'll put this on the right side of the equation. Let's put this on the right side of the equation, and the one that is given, we'll put that on the left side. So if we put this on the left side, what we have is, it's one and same. 1 mole of sodium equals to 23 gram of sodium, or 23 gram of sodium is 1 mole of sodium. It's one and same. So now it's exactly the same as the one that we have dealt just a while ago. Here we had a scenario like this: 3 chocolate costs you 2 rupees, 5 chocolate will cost you how much? Now exactly like that, what we have is 23 gram of sodium is 1 mole of sodium. Now 46 gram of sodium would be equal to how much? Would be equal to how many mole of sodium? This is the question that we have. Okay, or instead of thinking it as sodium, let's take it sodium as the chocolate that we wanted to buy. 23 chocolate costs us 1 rupees. So what will be the price for 46 chocolates? Okay, so what did we do earlier? What we have done was, we have divided by 23 on both the sides, so that we can get the price for 1 chocolate, or here like it would be 1 gram of sodium. And then what did we do? We multiply it by 46, since we want it for 46, so we are going to multiply it by 46. So that is 46 1 times is 46 gram of chocolates, and here 1 by 23 into 46, so 23 2 times are 46, so that would give us 46 gram of sodium equals to 2 mole of sodium. It's very simple. It is as simple as buying a chocolate from a store. Now let's deal with some more other questions. So let's say we have another question like this. Let's drink a glass of water. Okay, let's have a glass of water. Now if the glass of water has got 6.02 into 10 to the power of 25 molecules of water. Okay, if it contains this many molecules of water, then what is the number of moles? Then what is the number of moles of water which is there in that particular glass? Okay, and what is the volume of water that you're going to drink? So this is the question that we have. Okay, so in the given glass of water that is being provided to us, we have this many molecules of water. We have this many molecules of water. Now the question is, what is the number of moles of water that we are going to consume, or what is the volume of water that we are going to take? We don't need to worry about this. So first thing first, what we're going to do is always remember that we are going to use the idea of mole constant. So what we understand is, just a while ago that I have told you, the one that is given, we always put that on the left hand side, and the one that we have to find, we are going to use that on the right hand side. Okay, so let's remember this and use the idea wisely. So what we have is, we are given this molecules, so we're going to write the molecules on the left hand side. 6.02 into 10 to the power of 23 molecules of water. That would be 1 mole of water. And as per the given question, we have how many molecules of water? 6.02 into 10 to the power of 25 molecules of water. So this is 6.02 into 10 to the power of 25 molecules of water. What is the number of moles that is present in this amount? Now if we simply think it this way, just like the earlier case, 6 chocolate cost us 6 into 10 to the power of 23 chocolates cost us 1 rupees. So what will be the price for 6 into 10 to the power of 6.02 into 10 to the power of 25 molecules or 25 chocolates? Okay, it's very simple. So what we're going to do, we are going to divide it by 6.02 into 10 to the power of 23 on both the sides, so that you get the mole for 1 molecules of water. So 1 molecule of water will have 1 by 6.02 into 10 to the power of 23 moles of water. And what is the value that we need? The value that we need is 6.02 into 10 to the power of 25. So we're going to multiply this 6.02 into 10 to the power of 25. So let's multiply with this number on both the sides, 6.02 into 10 to the power of 25. So this would come out to be 6.02 into 10 to the power of 25 divided by 6.02 into 10 to the power of 23. So if it cancels out, we will have 10 to the power of 2, that is 100 molecules of water. 100 moles of water, I mean 100 moles of water. So that means in that particular glass of water that we're going to drink, which had 6.02 into 10 to the power of 25 molecules of water, so that water technically contained how many moles of water? 10 to the power of 2 moles of water. Okay, so the next question is, what is the volume of water that you're going to drink. So the second part, the volume of water. So what we understand is 6.02 into 10 to the power of 23 molecules of water. This is same as or equal to 1 mole of water. The water molecular mass is 18 gram of water, and this many molecules of water, its volume is 22.4 liter. So since they are asking us to find the volume, okay, so what we're going to do, we are going to cancel this two out. Okay, we don't need this. Since we don't need them, so we don't have to use it. Okay, according to the situation, okay, you use them wisely. So since we need the molecules and we need the volume, so as per the given condition of the problem, we are going to proceed. So what we have is, we know that in this many molecules of water there is 22.4 liter of water. Now if we have 6.02 into 10 to the power of 25 molecules of water, then what is the volume of water that is there in that particular glass? This is the one that we want to find. So what we're going to do again, this is exactly the same as 6 chocolate costs you 22 rupees, let's say. So what will be the price for this many chocolates? So what we're going to do, we are going to divide this with 6.02 into 10 to the power 23 on both the sides. When we divide this on both the sides, we get like 1 molecule of water. 1 molecule of water will have this many volume, but we want it for 6.02 into 10 to the power 25. So we are going to multiply it by 6.02 into 10 to the power of 25 on both the sides. Okay, so if we multiply this 22.4 liter divided by 6.02 into 10 to the power of 23 at the denominator and 6.02 into 10 to the power of 25 at the numerator. So what we have is 6.02 cancels out, 23, this is 10 to the power of 2. So our answer comes out to be 22.4 liter, 22.4 into 10 to the power of 2 liter. This is the volume of water that we are going to consume. Okay, so this is the water which had this many molecules, and what we understand is if it contains this many molecules, its volume will be this much. Okay, it's very much relatable. Now let's take some more other interesting questions which we can relate. What we have is, let's say for example, we went to a birthday party, and there we were blowing some balloons. Okay, we were blowing some balloons. Now in that balloon, what have you done? We have inflated the balloon by blowing the carbon dioxide from our lungs. Okay, by blowing the carbon dioxide from our lungs, we have inflated a balloon, and that balloon volume is 11.2 liter. Now the question is, what is the number of carbon dioxide molecules that you have introduced inside the balloon? And what is the number of moles of carbon dioxide that you have introduced inside the balloon? Okay, so let's say this is the first part and this is the second part. So let's try to find out. We need to always remember that we are going to use the idea from the mole concept first. So what we understand is, this is the given, the one that is provided to us, the liter, the volume. Okay, so we're going to use that on the left hand side. So 22.4 liter of carbon dioxide is Let's do the part B first. 22.4 liter of carbon dioxide is 1 mole of carbon dioxide. So what they are asking us is, they are asking us the number of moles that is there in 11.2 liter of carbon dioxide. So let's divide it by 22.4 on both the sides. If we divide by 22.4 on both the sides, what we have is, we have the number of moles for 1 liter of carbon dioxide, and since we want it for 11.2, so we are going to multiply it by 11.2 on both the sides. So if we multiply by 11.2 on both the sides, this is the number that we are getting. Okay, so if we divide this, we get half. This is 2 times, so half is 0.5 mole. So the number of the moles of carbon dioxide that you have introduced inside a balloon is 0.5 mole. That is the number of moles of carbon dioxide that you have introduced inside the balloon. Now, what is the number of the carbon dioxide molecules? The number of molecules that we have introduced inside the balloon. Let's try to find this. Since we are going to find the number of the molecules, so since we are going to find the molecules, we are going to put that molecules on the right side. Okay, this we would put it on the right side, the one that we have to find. So what we have is, since the volume is already being provided to us, so we have 22.4 liter of carbon dioxide is 6.02 into 10 to the power of 23. This many molecules of carbon dioxide. Okay, this is something that we already know, and they are asking us to find the number of molecules which is there in 11.2 liter of carbon dioxide. So for that, what we're going to do, we are going to divide it by 11.2 on both the sides, so that we get the number of molecules for 1 liter of carbon dioxide. And what we want is, we want the value for 11.2 liter. Oh sorry, this would have been 22.4 on both the sides, divided by 22.4 on both the sides. So what we have is, we have 1 liter of carbon dioxide, that would have 6.02 into 10 to the power 23 molecules of carbon dioxide. Since we want it for 11.2 liter of carbon dioxide, so we're going to multiply by 11.2 on both the sides. So which means this should be 2 times, and this would come out as 3.01. So our answer would be 3.01 into 10 to the power 23 molecules of carbon dioxide. Okay, so that means when we are blowing a balloon of this much size or this much volume of carbon dioxide, technically we are introducing 3.01 into 10 to the power 23 molecules of carbon dioxide. Okay, I hope we are clear till this point of time. Now, how about simplifying these calculations further? So what we have is, we have, let's say, a question, and the one that we have done a bit earlier. Let's say the balloon scenario. Okay, we had 11.2 liter of carbon dioxide which was there in a balloon, and we wanted to find the number of moles which was there inside it, number of moles of carbon dioxide, and we also wanted to find the number of molecules of carbon dioxide that we have introduced. Okay, so instead of doing the calculations like we have shown a bit earlier, we have another way of doing these calculations. For that, we need to use this formula. We should be using this particular formula. So the formula is the number of moles is weight by molecular mass, and that is equal to the number of atoms or molecules divided by your Avogadro's number, that is 6.02 into 10 to the power of 23, and that equals to the volume in liter divided by 22.4 liter. This is something that we need to remember. So now if we remember this particular formula, we can directly get our answers. So how do we get our answers directly? Let's look into this. So what we have is, we have to find the number of the moles, and the volume that was being provided to us was 11.2 by 22.4. so which means our volume will be half is 0.5 mole. So this is exactly what we got a while ago, half for the number of moles. Okay, so instead of doing the calculations like this, we could also possibly proceed by simply applying this particular formula: number of moles equals to volume divided by 22.4 liter. Now we have to find the number of the molecules. So the number of molecules with respect to this, we have the formula like this. We have to find the number of molecules. So this is number of molecules divided by Avogadro's number, which is 6.02 into 10 to the power of 23, and the number of moles that we have. Just in any case, if you don't have the moles, then you can simply use the volume that is being provided to you. So volume is, let's say, 11.2, and this is divided by 22.4, so that is 1 by 2. So which means we have, or we will have, the number of molecules as 6.02 into 10 to the power of 23 divided by 2, so that would come out as 3.01. okay, so in a very simple way, without worrying much about how we are going to apply the logic of the calculations, we can simply introduce this particular formula, and by using the formula we can easily get the number of the moles, we can get the number of the molecules, and if they provide us the number of moles or the number of the atoms or molecules, we can also get the volume. And this formula, with this formula, we can also get the mass as well. So all of these are possible. So let's have a very quick review of what we have discussed so far. 1 mole is nothing but a collection of Avogadro numbers, that is 6.02 into 10 to the power of 23. The reason why we have used 1 mole is because we want to avoid dealing with some large numbers like 6.02 into 10 to the power of 23, which are in crores and millions. And this 1 mole of a substance, its mass will depend on the type of the substance that we are using. Let's say if it is sodium, then it is 23. If it is water, then it is 18. If it is ammonia, then it is 17. If it is aluminium, then 27. So 1 mole or this many particles will have the mass, and that mass would be considered as the molecular mass. If it is an atom, then it will be called as the atomic mass. This mass will have the volume, will have the fixed volume, or 1 mole will have the fixed volume, that is 22.4 liter. Now in the exam, or in the questions that we will encounter, they might possibly give us the number of the atoms, and they will ask us to find the molecular mass of the substance, or they will ask us to find the volume of the substance, or they would ask us to get the mole of the substance, or in other kind of questions they would possibly give us the mass of the substance, and they will ask us to find the atoms, the volume, the mole. It could be anything. So we have two ways of dealing with these questions. One way is the number of the One way is we are going to apply the logic of buying a chocolate from a store, and the other way was by applying the formula. So our formula was number of moles equals to weight by molecular mass, that is equal to number of atoms or molecules by Avogadro's number, and that is equal to 11.2 liter divided by 22 point, sorry, the volume in liter divided by 22.4 liter. Okay, so by using this particular formula, what we can do, we can get the number of the moles. If the number of moles is provided, we can get the weight of the substance, and if any of these are provided, then we can find the number of the atoms or molecules, or if any of these are again provided, then again if they're asking us to find a volume, then we can find the volume. I hope it's clear with every one of you. We would discuss more of the numericals related with the mole concepts, the kind of questions that we get in the various engineering or medical entrance exams. We'll talk in the other lecture videos. So I hope it's clear, and thank you.